I want to welcome you today. We are doing a webinar today, the role of forest biomass in addressing climate change. It is 3:02, so let's get started here. The presentation today is by Robert Malmsheimer, who's a professor of forest policy and law at SUNY College of Environmental Science and Forestry in Syracuse. And first thing, though, I wanted to tell you a bit about Froling Energy. If you don't know anything about us, we are a mechanical contractor, and we are focused on the installation of high-efficiency, low-emission commercial biomass boiler systems. We do some residential as well as commercial, but our focus has always been on the commercial side. And when we say that, we also mean schools, which has really been our biggest marketplace. There's a lot of schools that use their let's just say they're 50-year-old buildings and older, and they use high temperature heat, and biomass is just a great alternative. And we're talking about the rural areas of New Hampshire and Vermont. That's really our marketplace. You can see that schools and campuses, commercial buildings, industrial buildings, residential, multifamily buildings, we've got all different types of installations. Every building, especially because they're older buildings or existing buildings, they're not always easy to retrofit. We do a lot of different things in the boiler rooms to just completely renovate. Sometimes we'll come into a 50 or 80-year-old boiler room and tear everything out and start fresh, and you end up with the most efficient circulation pumps and as well as new boilers all the way around. So it's really our favorite kind of a job, is to do something like that. We are self-performing, and what that means is that if there are other things to be done on site, very often we'll get involved with those. So things like building a boiler building, a boiler house, renovating the heat distribution system, both inside and outside of the boiler room. We're capable of doing that. Peaking and backup boiler installation, which points to fossil fuels. We very often keep a fossil fuel boiler in case of just for backup and sort of a tandem running operation. We'll do project management and procurement, and obviously system commissioning is a big part of what we do. And then the bottom line is there's a lot of engineers online today. And just to say, project development, we assist engineers and architects and building owners with the feasibility, design, estimating, value engineering, that sort of give and take of back and forth of what happens when people are designing something. You go big, and then you sort of hone it down and make it all work. And then work with specifications, to be sure. We tend to be, in some ways, sort of an only game in town. There's not a lot of people with expertise, especially in the dry chip boiler area. So we're very happy to share our knowledge of that technology and make sure that the boiler systems are designed well, and they can you don't have to have a lot of second guessing once the bidding and the construction begins. So our speaker is Dr. Robert Malmsheimer, and I want to thank him for coming and taking his time to be with us this afternoon to share his insights and research on this important topic. He's a professor of forest policy and law at SUNY ESF in Syracuse. That is the State University of New York, and it's a College of Environmental Science and Forestry, where his research focuses on forest carbon accounting and public policy. That's how laws and the legal system affect natural resource management, including how carbon accounting policies affect forest and natural resources. He's chaired 2 Society of American Foresters task forces that evaluated how forests and their products can best address climate change, and he's co-authored an analysis and summary of 135 peer-reviewed science articles on forest and biology. He actually co-authored the Forest chapter of the 3rd U.S. National Climate Assessment, and he's provided more than 100 science-based policy briefings to international policymakers. We're very happy to have him here today, and I want you to please welcome with me Dr. Robert Malmsheimer.
Thank you, everyone. It's nice to see some of you. Jason, I can see you with a baby. I haven't seen a baby in I don't know how long because of what happens with COVID. So if you see me smiling, that's why. I don't know if those of you who are on can see it, but it's been so long since I've seen a baby. God, it's weird. So good afternoon, everybody. Welcome. I hope you're all doing very, very well, and happy National Forest Products Week. You might not have known this is National Forest Products Week, but I wanted to to wish you that you're having a happy week. All right, so what I want to do today is spend some time discussing the role of forest biomass-based energy in addressing climate change. But in order to talk about forest biomass-based energy, I also need to talk about the role of forest products in addressing climate change. So my presentation will deal with both topics, and I hope that's okay with everybody. I also want to be clear about a few things regarding my presentation, since many of you may have seen something like this in your inbox advertising it. So first, I'm here because I was asked to give a presentation on the peer review science regarding bioenergy and climate change. Second, I want to be clear about something. I would never recommend that trees that can be used for other purposes, such as saw timber or as the feedstock for paper production, ever be chipped up and used for bioenergy. It makes absolutely no sense from a climate change perspective, and it makes absolutely no sense from an economic perspective. The third thing I want to make sure everybody understands is I'm not here to in any way advocate or suggest that all forest be managed to produce biomass-based energy. My goal is to provide science-based information on the climate change benefits that might be helpful to forest landowners who supply biomass and to building owners and operators who heat with forest-based biomass or are considering doing so. So just to be clear, to address climate change, we need a landscape of mixed forests, some that are managed or even not managed to maximize forest carbon stocks, others that are managed to maximize carbon sequestration, some that are managed to provide forest products and bioenergy, and some that are managed for a combination of all of those things. So where I'm going with all this is that this email did not accurately depict what I'm going to talk about today. So if you're here because you're expecting me to answer the question, should trees, all trees, in northern New England's forests be used for heating schools, commercial and industrial buildings, houses, and nursing homes, you're going to be disappointed. Why? Because what I'm going to talk about is this. What are the climate change benefits of using forest biomass that is a byproduct from the harvesting of trees for saw timber, or to meet landowners' management objectives, such as providing early successional habitat for birds, to heat buildings such as schools, commercial and industrial facilities, and nursing homes? My presentation is based nearly exclusively on the scientific peer review literature as well as IPCC reports. And as such, the take-home message is exactly what the IPCC says here about how forests can address climate change. Namely, that in the long term, a sustainable forest management strategy aimed at maintaining or increasing forest carbon stocks while producing an annual sustained yield of timber, fiber, or energy from the forest will generate the largest sustained mitigation benefit. So I hope you still want to stay around and hear my presentation. It wasn't a bait and switch, I promise you. But what I'm going to talk about is basically these topics. And my plan is to talk for about 45 minutes and then have about 15 or 30 minutes for questions or perhaps even dialogue if we can get it to all work. Never know these technologies today. To do that, I need to spend a few minutes to make sure we also understand some basic facts about climate change. And the first of which is understanding why climate change is occurring. So I'm assuming that you all have seen this figure before. We have years along the x-axis. We have parts per million of CO2 in the atmosphere along the y-axis. But what I want to ask you is, can you explain what is causing CO2 levels in the atmosphere to rise? And more importantly, can you do it in 4 or 5 sentences? I think that everyone who is involved and interested in climate change needs to be able to do that. We need to be able to simplify this a little bit. Not simplify it so it's wrong, but simplify it in a way that everyone can understand it. So let me tell you the way that I generally try to explain this in 4 or 5 sentences. For hundreds of thousands of years, CO2 levels in the Earth's atmosphere were relatively stable. However, about 200 years ago, they started increasing. Why? Because human beings started to do two things. We started harvesting forests at an unsustainable and in an unsustainable manner, and we started removing what is often referred to as geologic carbon, carbon that has been locked up in the earth for hundreds of millions of years in the form of coal, oil, and natural gas, and burning it to produce energy, and thereby releasing CO2 and other greenhouse gases into the atmosphere at a rate that the atmosphere cannot assimilate it. It's really that simple. By understanding this and understanding these basics of climate change, it's pretty easy to understand how to address it. Number one, we need to harvest our forests sustainably. So let me say that again because it came out as a tongue twister. We need to harvest our forests sustainably. And second, whenever possible, we need to not use geologic carbon to produce energy and products. So let's look at this in a little bit more depth. This IPCC graphic illustrates the problem. The width of the lines represent the amount of carbon moving between the atmosphere and various carbon pools. The red line, which is by far the thickest, indicating the most transfer, indicates the carbon being added to the atmosphere each year by the burning of coal, oil, and natural gas, and to a lesser extent, cement production. We can see this much better in this graphic. Notice how much the CO2 emissions from coal, oil, and natural gas have increased since 1960. So this really drives home why it is so important to minimize our use of these materials to produce products and to produce energy, which leads us directly to forests and why they are an important part of any climate change solution. Anytime that we can produce products out of wood rather than out of steel, aluminum, plastic, or concrete, or any of those types of materials, we are using what's called biogenic carbon, carbon that has already been circulating in the atmosphere. And therefore, we're not adding any geologic carbon to the atmosphere. And remember, it's the burning of geologic carbon that is primarily responsible for rising CO2 levels. As one of my co-authors, Roger Sedjo, who recently retired from Resources for the Future, put it, the carbon in trees is recycled carbon. It's already been in the atmosphere. The same can be said about energy. Anytime we produce energy from forest biomass rather than from coal, oil, or natural gas, we are producing that energy with recycled carbon rather than geologic carbon. And we are providing an important, real, and permanent climate change benefit. I also want to spend a little bit of time discussing the brown area on this graphic at the bottom, which has the label land use change. This is primarily deforestation. I also want to point out that while deforestation is an issue in other parts of the world, primarily the tropics, it is not an issue in the US as a whole. We can see this by looking at two figures. In this figure, the top line shows the extent of US forests. As we can see, since about 1900, the amount of forest lands in the US has remained relatively stable. But that's not the entire picture that we care about. As this graphic indicates or shows, since 1952, US forests have been sequestering more carbon than they have been emitting, which is what is indicated when the blue line dipped below the zero axis, when the blue line dipped below zero on the x-axis. Well, I also want to be clear that while overall US forests are sequestering more carbon than they are emitting, as this graphic from a recent article in the Washington Post shows us, that's not necessarily true in some parts of the US. Because disease and other disturbances such as fire are causing forests in some western states such as Montana, Utah, Colorado, Wyoming, and Arizona to now be emitting more carbon than they are sequestering. Well, since Froling Energy works mostly with clients in Vermont, and New Hampshire, let's spend a moment and look at those states' forests. The dark green line shows the extent of Vermont's forests from 1600 to today. And the red line shows the extent of New Hampshire's forests. As we can see, the extent of forest land in both states decreased until about the late 1800s, and then increased as former agricultural lands have naturally converted over to forests. Although, as the figure points out or shows, the amount of forest land in both states has fluctuated quite a bit in recent decades. Just like US forests, New Hampshire and Vermont forests are carbon sinks. In other words, they are sequestering more carbon than they are emitting. So since deforestation is not occurring in the US as a whole, or more importantly for us today in New Hampshire or Vermont, and hasn't been for more than 100 years, and since the US as a whole and New Hampshire's and Vermont's forests are sequestering more carbon than they have been emitting, one way for forests to address climate change is for us to use forest-based products and energy rather than products and energy produced by the geologic carbon in fossil fuels. If we were to ask most people, how can forests address climate change, what do you think they would say? I think the vast majority of them would say that forests can sequester carbon. And that's absolutely true. And here at ESF, we're working on ways that we can increase the carbon sequestration in our forests. However, as I noted earlier, forests and forest products can address climate change in other ways. So let's examine those. We'll start by looking at the products that drive most timber sales, namely saw timber. Saw timber are logs that can be milled into lumber and are used to produce products, such as those that we see in these photos. However, before I start, I want to make sure everybody understands why saw timber drives most forest harvesting. It's because landowners in the Northeast with northern hardwood forests receive 3 to 7 times more for their saw timber than they receive for wood that is not saw timber. These materials, which include forest residuals such as treetops or limbs, crooked and diseased trees, and trees that for one reason or another cannot produce saw timber, are often ground up to produce wood chips that are sometimes used to produce bioenergy. In fact, in a typical northern hardwood-based timber sale, saw timber provides landowners with 80 to 90% of the revenue that they receive from that sale. So chips only provide 10 to 20% of landowners' revenue. Now, I know a lot of you are concerned about the sustainability of our forests and that large trees are going to be used to produce bioenergy. But it's very important to understand that it never makes financial sense for logs that can be used as saw timber to be chipped up and used for bioenergy. Also, because wood chips are such a low value product, it's very difficult for landowners to make money conducting timber sales that only involve wood that can be used for bioenergy. That's not to say it doesn't happen, but when it does, it's often because the landowner is conducting something like a timber stand improvement project, which will then allow her to increase the revenue from saw timber in a later timber harvest. So that's a really important point that I think we want to make sure we understand. So given this, it's important for us to start our discussion with the climate change benefits of forest products, and then talk about the climate change benefits of bioenergy. To understand why forest products are a solution to climate change, we need to spend a minute dissecting this statement, which is based on the peer-reviewed literature. As long as wood-producing land remains in forests, whenever we can use wood products rather than products made from steel, plastic, concrete, or other products that require high amounts of fossil fuels for their manufacture and production, we do 2 things. Number 1, we reduce fossil fuel carbon emissions and get a climate change substitution benefit. And we also sequester additional carbon and get a climate change sequestration benefit. Two different benefits. The first thing we need to understand is that when we conduct life cycle assessments, we learn it takes less fossil fuel to produce wood products than to produce alternative products. So let me stop for a minute and make sure everybody understands what a life cycle assessment is, since the next two slides are based on this type of analysis. For those of you who don't know, when we conduct a climate change-based life cycle assessment of a product, we analyze the greenhouse gas emission impacts associated with all stages of the product's life, from extracting the raw material, to processing that material, to manufacturing it, distributing it, installing it, repairing and maintaining it during its lifetime, and then disposing of or recycling it. So this table here shows the megajoules of fossil fuels needed to produce 3 different products that are often used to support 1 square foot of floor. As you can see, using concrete in this situation uses 2.5 times more fossil fuels, more geologic carbon, than using steel. Let me say that again. Using concrete in this situation uses 2.5 times more fossil fuels than using wood. And using steel uses nearly 5 times more fossil fuels. And just refreshing our recollection, what's the problem with this? These emissions of geologic carbon are what are causing increasing atmospheric CO2 levels to rise, or increasing atmospheric CO2 levels. We can use LCA to analyze the CO2 emissions associated with individual building materials or with assembled building materials, which is represented here. So let me explain a few things about this graphic. Let's look at the horizontal line in the middle of the page. Below the line, you see different components that can support a floor. Above the line, you see the different components that can comprise a floor. Next, let's look at the vertical line that's in the middle of the page. Bars to the right of this line indicate when a square meter of floor using these materials releases CO2 into the atmosphere. Bars to the left of this line indicate when a square meter of floor using these materials sequesters CO2 in these materials. So for example, the CO2 emissions associated with a wood dimension joist to support 1 square meter of flooring, when we take into account the carbon emitted from the harvesting of the tree, the transporting of the log, the making of the joist, the transporting of the joist, the installing of the joist, and then the disposal of the joist, is less than, is less carbon than is stored in the joist. So more carbon is stored in the joist than is emitted, which provides a climate change benefit. And when we use wood dimension lumber and plywood to create 1 square meter of floor, there is a net of more than 30 kilograms of CO2 stored in the floor than are emitted in the process required to create that floor. I also want to point out that while we're talking about carbon emissions, there are other benefits to using wood. Here's an analysis of both the climate change impact in the left column and the overall environmental impact in the right column of making a floor out of different materials, using the criteria at the bottom of the slide. As you can see, wood performs very, very well, not only when we're dealing with climate change, but also when we're dealing with other factors. All of this is why there's so much interest in mass timber buildings, for example, since they show us how using forest products provide both a sequestration and a substitution benefit. Let's start by understanding what a mass timber building is. We're talking about high-rise buildings, 5 to 20 stories tall, that are generally used for commercial and/or residential purposes. Traditionally, these buildings have been created using steel and concrete primarily. Mass timber buildings provide a sequestration benefit because the wood in them is actually sequestered carbon, since 50% of wood by mass is carbon. So when we build buildings out of wood, we are sequestering additional carbon, carbon that we would not be sequestering if we built the building out of steel or concrete. In addition, because we are not using as much steel and concrete, or any, but usually we use a little still, but not always, but because we are not using steel and concrete, two products that produce significant fossil fuel-based carbon emissions when they are mined and manufactured, which recall is the main factor driving increased levels of CO2 in the atmosphere, we receive a substitution benefit. Now, I want to be clear. Harvesting, transporting, and manufacturing wood currently does require the use of fossil fuels. But doing so uses significantly less fossil fuels, often less than 10% of the fossil fuels required to mine, manufacture, or transport steel or concrete. Here's an example of the sequestration and substitution benefits in a building on the University of Washington's campus. Now, I know what you were thinking. Okay, Bob, I'm with you. I understand that wood products sequester carbon in the wood itself. But at the end of the product's useful life, the carbon from that product will be emitted into the atmosphere. So of course, some of you are thinking, Bob, that sequestration benefit that you were talking about, that's only temporary, because at some point the product reaches the end of its useful life. So let's talk about that. Two things happen when a forest product reaches the end of its useful life. Number one, it's disposed in a waste-to-energy facility. That's what happens here in Syracuse. When that happens, we get a second substitution benefit because we're producing heat and/or electricity without using fossil fuels, something that we'll talk about more in just a few minutes. If it's disposed of in a landfill, most of that wood is permanently sequestered because US laws regarding landfills require anaerobic environment or create anaerobic environments in those landfills. In other words, the waterproof caps that we place under landfills and on top of landfills do not allow air into the landfill. So more than 3/4 of the wood products in those landfills do not decay. How do we know this? The US Forest Service has actually dug up multiple landfills and measured the decay. So now that we understand the climate change benefits of forest products rather than products made from steel, concrete, aluminum, or plastic, I want to talk about the role of that forest biomass-based energy can play in addressing climate change, such as using wood chips in boilers to heat buildings, which is why I think most of you are here. Before talking about this, I think it's important to understand how much energy the US gets from bioenergy, because I don't think that most people realize that 5% of US energy is from biomass. As this 2017 energy production graphic shows. This graphic is based on 2019 energy production and provides a little bit more information about that wood and waste waste-based energy. I wanted to include it because when I tell people that biomass provides approximately 5% of the US's energy, they usually say, okay, that's corn-based ethanol and biodiesel. But as this slide indicates, only about 46% of US energy is currently from those products. Most bioenergy is actually from burning wood-based biomass, and 24% of that is used to heat commercial and residential, used in the residential and commercial sector. In fact, wood waste-based biomass provides nearly 60% of the renewable energy used in the commercial and residential sector. To understand why bioenergy is a solution to climate change, we need to spend a moment dissecting this statement, which is also based on the peer review literature. As long as wood-producing land remains in forests, whenever we use wood-based energy rather than energy from burning coal, oil, or natural gas, we reduce fossil fuel carbon emissions and get a climate change substitution benefit. So let's look at an example. This figure shows the CO2 emissions from wood boilers that use fuel oil, propane, and wood chips. I should also note, wood pellets. I should also note that because we use less energy to produce wood chips would have a lower total CO2 emissions than wood pellets if they were represented on this figure. Notice how the total CO2 emissions from the wood pellet boiler are similar to the fuel oil boiler and more than the propane boiler. However, that's only part of the story. If we factor in that we're using biogenic carbon sourced from sustainably managed forests, which we are if we're using biomass from New Hampshire or Vermont, we can see that the fossil fuel emissions are only a fraction of those produced by using fuel oil or propane. And remember, as long as we are sustainably managing our forests, these are the emissions that we care about, because they're the emissions that are causing CO2 levels in the atmosphere to rise. This is why the Germans and the Danes are working on ways to convert some of their district heating from fossil fuel-based fuels to biomass. Now, I know some of you are thinking, okay, Bob, that makes sense, but what about carbon debt? What about that carbon debt that occurs when we harvest forests? So that's a great question. Let's look at it. We need to start our conversation by understanding that the carbon debt debate is about the timing of climate change benefits in a particular stand. So let's look at the two concepts that I have here in bold. Let's start with the second because it's a little easier to think about. The carbon debt concept addresses the idea that if we remove some or all of the carbon in a stand when we conduct a timber sale, it takes time for the forest to regrow and for that carbon to be replaced in that particular stand. That's absolutely true. But notice that the focus is on that forest stand. But to understand what's happening with carbon across the landscape, we need to examine what's happening with carbon stocks across 10 stands or 100 stands. And as this figure shows, when we do this for a landscape that is sustainably managed, at any given time we see a mosaic of stands, some of which have recently been harvested and have large carbon debts, and some of which have not been harvested recently, so they have reached their previous carbon stocks or exceeded that stocking. So these stands have little or no carbon debt. More importantly, when we look at sustainably managed forested landscapes composed of thousands of stands or tens of thousands of stands, such as looking at what's happening in the states of Vermont or New Hampshire, we see that carbon stocks are much more stable. And we get a much better indication of what's happening with carbon in our forests. In fact, when we do this for Vermont and New Hampshire, we see that carbon stocks are rising. In other words, overall, we're increasing the carbon in our forests despite the fact that individual stands may have a carbon debt. Now, to be clear, the carbon debt concept is valid, but it's a concept that applies to what happens with carbon at the forest stand level. However, what's happening at the landscape level is much more important from a climate perspective. The second concept we need to discuss is the timing of the climate change benefits. The idea here is that the short-term emissions from using forest biomass to produce energy are sometimes higher than the short-term emissions from using geologic carbon fossil fuel-based sources. I want to emphasize that the carbon debt debate is about the timing of benefits, not whether those benefits exist given enough time. However, according to the IPCC, it's the long-term cumulative CO2 emissions that are going to be correlated with projected peak global temperature. And using forest products and bioenergy reduces these long-term cumulative emissions. Why? Because forest products and forest bioenergy from sustainably managed lands release mostly biogenic carbon, carbon that's already, as I've said 100 times here, I know, already been circulating in the Earth's atmosphere. And therefore, this carbon does not increase long-term cumulative CO2 emissions. Also, I want to be clear here. Forest products do release small amounts of geologic-based carbon emissions. So for example, the gasoline that we use in a chainsaw, the diesel that we use to transport logs. So they do increase cumulative CO2 emissions slightly. Conversely, fossil fuel-based products and energy emit geologic carbon, carbon that increases long-term cumulative CO2 emissions, the emissions that are causing those CO2 levels in the atmosphere to rise. Why is all this important? Because as I said, the fifth IPCC assessment states that it's the long-term cumulative CO2 emissions that are correlated with peak global temperature. So if we want to limit global temperature increases to 1.5 degrees centigrade or 2 degrees centigrade, one thing we can do, and there's lots of things we can do, but one thing we can do is that we can use forest products and bioenergy from sustainably managed forests rather than fossil fuel-based products and energy, because doing so reduces long-term cumulative CO2 emissions. Now, I want to be clear, for all this to be true, we need to be sustainably managing our forests. But as actual forest inventories, not modeling and projections that are used in some other countries, but actual inventories have shown, we're doing this in this country and we've been doing it for decades. And we currently have a system of federal, state, and local laws and best management practices that ensure that we are going to continue to do this. Now, just to be clear, because I always want to be absolutely transparent on all of this and honest about all of this. Here's the IPCC statement. The IPCC's findings on the factors that impact peak global temperatures are very clear and based on multiple lines of evidence. Among the various human-related causes, it is cumulative CO2 emissions that are likely to drive those peak global temperatures. But also, to be clear, the IPCC does advocate reducing some short-term CO2 emissions. But its emphasis on reducing short-term CO2 emissions is driven primarily by concerns about is driven primarily by concerns about the lock-in of technologies that increase long-term cumulative CO2 emissions, such as adding new coal or natural gas-based power plants, which, because of the significant financial investments that need to be made in building these facilities, may cause society to be locked into using those fossil fuels in those facilities and thereby releasing geologic carbon into the atmosphere for decades. Before I end, I also want to briefly discuss the importance of forest markets. Many people are worried that if we start using a lot of wood to produce products and energy, that we'll start managing our forests in an unsustainable manner. So I want to mention something that's relatively unique about US forests and has been documented in the peer review literature through temporal observations, empirical studies, and extensive sophisticated modeling. Namely, that because of the private property rights system that we have in the US, markets for forest products and forest biomass encourage and lead private landowners to do two things: to increase the amount of forest lands in the US, primarily by converting agricultural lands to forests. Where we have markets, landowners are willing to and have been shown to be willing to allow lands to either convert naturally or to plant lands, marginal agricultural lands or pasture lands into forests. So we increase the amount of forest land. Number two, it leads private landowners to invest in management practices, such as timber stand improvement projects and things like that, that increase the productivity of their forests, which increases forests' ability to sequester additional carbon. This is why our forests have sequestered more carbon than they have emitted for nearly 70 years, while supplying forest products and energy that has fueled economic expansion during a time of a large increase in the US population. So I want to end where I began, with the IPCC's statement about forests and climate change. Namely, in the long term, a sustainable forest management strategy aimed at maintaining or increasing forest carbon stocks, a very key thing that we need to be aware of, while producing an annual sustained yield of timber, fiber, or energy from the forest, will generate the largest sustained mitigation benefit. So I hope this was useful. I hope it was worth your time, and we've got some time for questions, I believe. And so I'll let Jim decide how we're going to do the questions, and I will stop sharing my screen so we can see each other.
Okay, that's good. That's good. And I'm sitting here without a video, so sorry about that. Bob, bring up the chat box and you'll see a number of questions there right now. There's an early one that came in, and it was from Jonathan Parrott. He says, while we can all agree that carbon stocks are important, I believe that it's equally important that we recognize the necessity of increasing the rate of carbon sequestration. The only way to influence the rate which a landscape may capture carbon is via the responsible harvest of durable forest products. It's a statement, I guess. Do you agree with that? Is that?
Yeah, I believe, yes. So the answer is yes. Let me start there.
Okay.
I was waiting for the question, by the way, but it is a statement. Let me start by, I'm going to take what Jonathan has said here and make sure everybody understands the difference here. What Jonathan is really bringing up is he's bringing up the idea that there is a difference between carbon stocks and carbon flux, right? Carbon stocks, carbon stocks are the amount of carbon that is stored in a forest. Carbon flux is the amount of carbon that is either being emitted from that forest or being sequestered by that forest. It is a function of stocks, but they're two different concepts. And so it's really important for us to keep those in mind. And why are they important? Well, they're important, for example, because, for example, here in New York State, we have a law, probably as a matter of fact, I know it's the most aggressive climate change piece of legislation in the United States, one of the most aggressive in the world. It requires us by the year 2050 to reduce our greenhouse gas emissions by 85% and to offset that remaining 15%. Well, forests can provide some of those offsets, right? Or they're probably going to provide most of those offsets. But when we're talking about offsets, we're talking about carbon sequestration. We're not necessarily, that's the currency involved in determining whether we've met that particular goal of net zero emissions by 2050. So, Jonathan, you bring up a very good point about this idea, and harvesting is an important tool that we can use to ensure that the rates of sequestration are that we have high rates of sequestration or increasing rates of sequestration. Now, of course, we have to maintain those carbon stocks, right, on the landscape as a whole. So, I hope that addressed that.
All right, the next
if you
one
can
is
kind of moderate, because there's a lot of other things in here. If you can kind of tell me the next question, that would be helpful to me.
Yeah, the next one is let's see here. It says it's by Far Mice, and it's at 346. So I'm curious the definition. Go ahead. I'm curious about the definition of sustainably.
Sustainably harvest in the peer review literature and how that definition stands up with existing regulations. So, wow, that's packed with a lot of stuff. So let me try to get at that. First of all, there are multiple definitions of sustainably harvested, right? When you write a paper, you basically decide what your definition is. I think what most people are looking at is the idea is, at least from a climate change perspective, are we looking at forests that have where the carbon stocks on those forests are relatively stable or increasing, okay? That those forests would be considered to be sustainably harvested. Now, I want to be clear. We have to be a little careful here. And I know I'm getting into the weeds, but we have to understand that forest carbon stocks have been going up and down in our forests for decades, right? Those lines that are on those figures that I'm showing there, they're not perfectly straight lines. What happens is, right, sometimes when timber prices go up, you have more harvesting. When timber prices are low, you have less harvesting. That influences forest carbon stocks. The other thing that most people don't think about that influences forest carbon stocks more in the US South, but does have some influence here, is the idea of when we give incentives to people to plant forests on their lands. So for example, when we used to have the FLIP program that was administered by the Natural Resource Conservation Service, we paid, that was a cost share program, and it allowed landowners to plant forests on their land. Well, those forests, as they mature, there's a whole group of forests that are planted in a period of time when that program was in existence. And those forests, as they mature, they influence what happens with the forest carbon stocks on the landscape as a whole. So, you know, it's a very good question, a great question. I hope that I've kind of answered it. I know I danced around it a little because I can't really say, you know, that there's one definition. And to be honest with you, after talking for 45 minutes, I can't really remember if there's, you know, the specific definition that's used most often. But I would say it was based on that concept. So I hope that was helpful.
All right, Bob. The next one is, you know, by the way, just one thing I wanted to point out is that, you know, you talk about the normal way of managing a forest by owner best interest and by everybody else's sort of best interest here and foresters. We have a presentation that was done back in June or July and it was on biomass sustainability. And basically it was a forester that was just talking about what really goes on in the woods and how things are lined up, and some of the things that you were talking about where the priority is saw timber, and then this other the low-grade wood just goes around. They have to cull it out and so forth. It's a really good presentation, so I just recommend people check that out. So sustainably harvested, I agree. That's an interesting one to talk about. Okay, here's one from Mike Davies. Do you want to read that one, Bob? It's right after this one, 346.
346, okay.
Mike
yes,
Davies.
Thank you for the accolades. I'll always accept them. You mentioned that most deforestation is in the tropics. What is the best method to tackle this? I'm going to stop right there because I will tell you I only specialize or only deal with U.S. forests. I don't deal with unfortunately, I don't deal with forests in the tropics or in other places in the world. I'm only really qualified to talk about U.S. forests. So unfortunately, Mike, I can't answer your question. But I'm sure there are many people out there who can, but it's not me. Sorry about that.
Okay, how about Hugo Lundberg? That's at 347.
All right,
Next.
If we take a sidestep and look not only at sustainability from a CO2 point of view, there is also a concern that aiming for higher productivity will lead to plantations, not real forests, with an impact on biodiversity and based on which species are planted. Hugo, you bring up a very good point, right? I wanted to talk today about forests. Forests provide multiple benefits, right? And so it's very important to understand and to think about when we think about from a societal point of view, that's forests able to provide all of those benefits and continue to provide all of those benefits. I think what we've seen is that forests can, if they are sustainably managed, are able to provide not only all those benefits that we look for from recreation and wildlife and all of those other things that we get from them, but also to provide climate change benefits. Now, your question about plantations is an interesting one. All right. I think we have to be a little careful here because we have to kind of think about this, right? There are some, I know people are going to start cringing in a minute, but there are some advantages to plantations, right? Because we are concentrating the production of forest products in a smaller area, which can mean that we can have areas, forests, other forests that are managed for other things. So it can mean that, right? It's based on a societal point of view. I also want to point out, because my colleague Tim Volk would be a little unhappy with me if I didn't point out, for example, Tim does a lot of work with willow, and using willow potentially as an energy crop or for other reasons. And what some of the work that Tim has found is that things like planting willow in an intensive manner actually does provide some biodiversity benefits. So I think I've danced around your question, Hugo, quite a bit, but I think I just want to go back to this for a minute, right? I mean, unless we're going to decrease consumption dramatically, wood is got to come from somewhere, or we're going to use those fossil fuel-based materials, right? At least for our building materials, right? And so we have to think about this. The other thing that I hope that you all are thinking about is, you know, when we think about wood, we're concentrating here on using wood for boilers, because that's what Jim asked me to talk about. But, you know, wood is going to be, biomass is going to be one of the feedstocks that we're going to need to be able to use also to decarbonize some of the very hard to decarbonize sectors that we need to decarbonize to get to that net zero, or in New York State to get to that goal of an 85% reduction in greenhouse gas emissions. So if you look at the report by the consulting firm E3 that was prepared for the New York State Climate Action Council, what you see in that report is you see E3 saying we need biofuels for decarbonize, or at least partially decarbonize, sectors like aviation and things like that. We need biofuel, we need biomass to provide feedstocks to replace our petrochemicals and our plastics and things like that. So we have to think about biomass. We're talking about energy, but we have to think about biomass broadly. Now, once again, there is a limited supply of biomass. We need to do this sustainably. I always want to say that. But it's important to think broadly about, you know, how are we going to address climate change? So once again, Jim, I'm sorry, I went off on a real tangent. I'll try to be more distinct in my answers.
That's good. There's a lot of buzz things that you just get caught up in it. It's easy to do. You know, one thing Mark always says is that you cut, you know, the typical forester, and Mark Froling, I should say, the president of our company, but you go into a forest as a forester and a logger and you pick out trees and you're going to keep the young ones that are good and healthy and you're going to, you know, foster them. So the typical stand in New England is we end up having these trees that are at various stages in the forest, and they actually keep them. They don't just clear cut. They just pick around and they say this one. And then the next thing you know is that these trees are springing up like weeds all over the place. And you get these natural, you know, the typical assortment of species back into the forest again. It just keeps continuing. There's a lot of seeds in the ground that just start to erupt. But that's sort of a natural thing. We can't stop forests from growing around here. It's like all those fields with the stone walls in them that used to be fields. Anyway, go ahead. Next one is anaerobic sequestering means methane. Well, not carbon. It's the leading issue in the climate debate. That's from T. Stillman.
Sure, and I agree 100%, T. And I believe what you're referring to here is when I was talking about landfills, and that landfills are anaerobic environments. Yes, they will produce methane. What we're seeing is those landfills are actually being capped, and we hope that we are providing mechanisms to set up systems where that methane is captured, hopefully not just flared, hopefully actually captured, collected, and then utilized. But yes, you're absolutely right. That's a very good point. I don't know if you noticed, I hesitated at the end of that slide. I was going to mention that, but I didn't know how much that would take me off on a tangent. So thank you, T. I appreciate that.
Okay, let me ask you the next one. D. Anderson says, address current depressed state of the low-grade wood markets in New England. Why does the market not reflect or recognize the carbon substitution benefits? This is a basic supply exceeding current demand. Or competition from cheaper on the ISO New England grid, the dollar per kilowatt natural gas from fracking, geologic carbon, cheaper on the grid. That's, there's maybe some words missing there, but you get the gist?
Yeah, absolutely. I think the answer to that question is relatively easy. And the answer is that we are not putting a price on the negative externality that is caused by emitting greenhouse gases. If we had a carbon price, I know people are going to cringe again. If we had a carbon tax, right, those fossil fuels, and that carbon tax was based on the social cost of carbon or some cost of carbon, the environmental damage caused by the greenhouse gas emitted, right? Those fossil fuels would be priced more expensively. Biomass and low-grade biomass would be able to compete. So I think a lot of that is based upon the fact that we don't have that mechanism. And I know you're going to cringe again. I'm sorry. I'm just trying to be honest here. It's the same thing with nuclear plants, right? I was just listening to a podcast from the Rocky Mountain Institute where they were talking about this, right? Why are we propping up nuclear plants? We're propping up nuclear plants because nuclear plants have to be propped up because they're not receiving the benefit of producing electricity that doesn't produce greenhouse gases or doesn't produce large numbers of greenhouse gases. Now, I know there are many problems with nuclear plants. I don't want to get into a debate on nuclear plants. I'm just trying to point out, though, that by not having a price on carbon, right, it allows fossil fuels to compete in these markets and to continue to increase those levels of CO2. I mean, that's really the issue. So that's a great point. Thank you.
Yeah, there was a thing here in New Hampshire where we have a number of wood plants. I think there were 6 of them total. And a number of them were shutting down and have shut down because there was a little benefit that the government was giving them to try to keep them running because natural gas was so cheap that they needed this kind of support. They couldn't be competitive on the market. So there were like 3 vetoes, I think, involved from the governor that would not allow these guys to get that subsidy. And it's basically what you're talking about. These are beneficial, and yet they're not. There's also negatives to say about those plants because they're very low efficiency, they're wasting a lot of heat, and it's just kind of foolish. But I think that's an evolutionary thing. We need to get to some really nice cogeneration and that kind of thing. That would be the way to go on that. But that's sort of a future thing. We can't just convert these things tomorrow. So unfortunately.
So, and Jim, I want to point out one other thing about low-grade markets because I think it's important.
Yep.
Where low-grade markets don't exist, and in some parts of New York, we don't have low-grade markets. Where they don't exist, that does 2 things. For those forest landowners who are on, really are having a difficult time affording to own their forest land, not being able to get that extra 20 or 10 to 20% of revenue from a timber sale can be the difference between them owning that property and them not owning that property. For forest owners who are not in that position, it can be the difference between doing something that might increase the storage of carbon in the long term and not doing it, right? Because those markets matter. They provide mechanisms to get a little bit of more money, but they also provide the mechanisms to do timber stand improvement projects. So anyway, sorry about that. There was another one I just saw.
Gabe, you see Gabe
here.
Roxby there? 351, Gabe. Thank you for another accolades.
I was interested in your slide stating that increased demand for wood can increase forest area and also productivity. I think this is an important point. And would you be interested in reading the literature on this? Can I point you to the research? I can. It's actually the publication that Jim mentioned when he introduced me. It's in the Journal of Forestry, December of 2015 or 2014. And if you send me an email, Gabe, I'll actually send you a copy of the article. The article summarizes all that literature that is in that one slide, that forms the basis for that one slide. Also, there was one from Joel up here. To what extent do you think sustainably managed forests could draw down atmospheric CO2? Pretty tough to do and still provide housing and food and things like that to nearly the 8 billion people that we now have on this planet.
Yeah.
It'd be pretty hard to do. So on the other hand, though, if we got BECCS, right, bioenergy, carbon capture and storage, then we can start to draw down some of that CO2. And I urge you all, I don't really have time right now, but I urge you all to understand the difference between just carbon capture and storage and bioenergy carbon capture and storage. There is a big difference in the climate change benefits from using carbon capture and storage in a fossil fuel based emissions than on using it in bioenergy based emissions. When you use it with fossil fuel, you're not adding an additional carbon, but you're not taking any carbon out of the atmosphere. If you use it with bioenergy, BECCS, bioenergy carbon capture and storage, you actually have set up a negative carbon technology, which can decrease those levels of CO2 in the atmosphere. We should be, in my opinion, this is world according to Bob, we should be setting up a system where we are giving more incentives for BECCS than for carbon capture and storage. Doesn't mean we shouldn't have carbon capture and storage, but from a climate change perspective, there's more value in BECCS than there is in just carbon capture and storage. Let's see. T asked again, can cellulosic insulation be made out of the same forest products as biofuels? I'll always tell you when it's beyond my bailiwick, and that one's beyond my bailiwick. I believe so, but I don't know. So
I think
cellulose on that question.
Isn't cellulose insulation basically newsprint that's been recycled, or paper that's been turned into like a pulverized, which is trees. I think, and ultimately it's in that ecosystem.
It can, but
yeah.
Jim, I always been one of these people that if I don't know
Get
the
away
answer,
from that.
I just come right out and say it. So
let's just move on.
I believe you're right, but I don't want to get in. I don't want to say something that's not necessarily true.
No problem.
Let me find another question.
Is Hugo at 352. In addition to sequestration and substitution, I think there is a positive effect on carbon that comes from the fact that deriving value from forests enables us to maintain them. And keeping forests as a carbon stock does not bring income unless we start paying for that. Unmanaged forests can lead to problems such as forest fires. So in other words, that idea of a forest that does nothing, you just leave it sit there, versus one that's managed and maintained. So.
Sure, and I guess what I would say to this is there are benefits to both, right? I think that we really do need a landscape that has forests that are managed for high carbon stocks, forests that are managed for high carbon carbon sequestration, forests that are managed for products and energy, forests that are managed for all of those things. We need a mosaic out there on our landscape, and if we do so, that landscape will have the most resiliency. Right, and in all likelihood can provide the most benefits out there. So there are issues. It is important to understand there are issues with unmanaged forests, but it's really, I think, a mosaic that we want to have. And the other thing I just want to point out, I said it before, I want to say it again. I am in no way saying if you are a forest landowner right now that you should manage your land for bioenergy or you should sell chips or anything like that. I'm just trying to provide you with information about what are the climate change benefits of if you decide to do that, are there benefits and what are they? That's what I'm trying to do. It's your decision. You're the person who owns the land, right? Within the realm of that society gives you the sideboards on. Let's see.
353, Richard Zell. There you go. Go ahead. From your perspective,
which forest practices make the best contributions to enhancing stocks or reducing greenhouse gas emissions? Longer rotations, maintaining older trees, eliminating slash, others. Wow. So I am not a silviculturalist. I am actually an attorney. And now everybody's going to hang up. It depends on the forest, doesn't it? It depends on what kind of forest it is. Right, and it depends on what you're trying to do. If you're trying to manage for enhancing stocks, that's different than if you're trying to manage to increase sequestration. And depending on the age of your forest and the diversity in your forest, all of those things matter. I think we are seeing there's a lot of educational programs out there for foresters, and foresters are learning more and more and understand better and better if you as a landowner or somebody as a landowner has a goal and that you articulate, a forester will be able to help you achieve that goal. But it's up to you to determine what that goal is. Now, I just want to say, in general, and I am stereotyping here to make this a generalization. Older forests have higher carbon stocks. Younger forests, in general, younger rigorously growing forests sequester more carbon in general. Okay. Now, with that said, realize that in New England, as in New York, we have patchwork, right? We have some wind throw. We have a huge dead tree that dies. And we've got a mix of older trees next to younger trees and things like that. So I was generalizing there, but I guess trying to, Richard, to address your question at least a little bit. The plantation question points towards the current scale of privatization of equity. The past 70 years doesn't reflect that. T. Stillman, thank you for that. I'm not sure that's really a comment. I'm not sure I can really comment on it. Yeah, I'm not sure that's really a question I can answer. All right, let's see. In simple terms, what really causes the aggressive and continued escalation of the rate of California wildfires, and how to reduce that, through responsible forestry? So I think what we're seeing in California is we're seeing that we have, forests that we have suppressed fire in fire-dependent ecosystems, or ecosystems that may not be dependent on fire, but that experience fire on a regular basis. And therefore, we have high fuel loads in those forests. In addition, California has been in drought for years and years and years. Yes, some years it's out of it, but there's long-term drought there. And therefore, we have a lot of dead trees because of the stresses that drought places on those trees. Many people believe, and I'm not saying it's not true, I'm just trying to state it as, that it's climate change that's causing that drought. But the answer to your question is you have high fuel loads, unnaturally high fuel loads, because of human suppression of fire, and also because of the drought. All right, D. Anderson, my last question, I think. What do you think is the greatest educational challenge regarding the public perception? Oh, I love this question. Public perception of forests and climate change and carbon. In general, public perception of carbon benefits of biomass energy is neutral or negative. So, did you notice it took me 45 minutes to tell that story? Right? I mean, that's how long it took me. This is not simple. And to be honest with you, that's why I did that thing at the beginning of this, right? It's not a simple thing to deal with this. This is complex stuff. And it takes a while to understand it. And you've got to be able to keep someone's attention for that time. My experience has been when you explain it to people, people understand, right? But the problem is, how do we get that message out there? More importantly, we need to get that message to both the public and to policymakers. And policymakers, and I'm talking about state legislatures and national policymakers, often have a smaller attention span for a particular issue than the public. And I'm not trying to put them down. They're trying to deal with everything, right? They've got to deal with mental health. They've got to deal with education. They've got to deal with climate change, tons of things. They have a very small window of opportunity to learn things. But it's not an easy story to tell. I think it's an important story. And what we need to do is to explain it in a reasonable way and explain it that, you know what, forests are a part of the solution. This is the last thing I'll say, and then I'll shut up unless there's more questions. Climate change is such an overwhelming issue to deal with. It scares the heck out of me every time I think about it. The challenge that we as humanity have. And we're doing this challenge and we're increasing the number of people on this earth. So we're making it even harder. And we have a short period of time to do it. In my opinion, World According to Bob, we need to use every mechanism possible to address this, right? We need to think hard and to be strategic. And we need to do things And we need to do them fast, but in a strategic way. And we can't let ideology get in the way of that. We need to base things on science and what the science tells us. And the other thing is that the science is changing. Scientists don't know everything. That's the wonderful thing about being a professor. I learn something new every single day, right? And so being able to understand that, you know what, if science told us something 10 years ago and now it's different, it's not because they were wrong, it's that they didn't understand it properly. They're trying to understand it properly. So anyway, I think we just need to continue to talk to people. And if there are people that you think that I could talk to that would help them understand this, I'm happy to do that. So I hope this was helpful to you all. If there are any more questions, looks like there's one more.
Yes,
yeah, can you read that one, Jim? I need
Sure.
to get another drink here.
Okay, it says, you've addressed, this is from Faramis. It says, you've addressed the pure literature around the link between forest management and harvesting and climate change. But do you have sources that assess the success of public policies meant to encourage keeping forests as forests, like current use, etc.? Do they actually work?
There are sources out there. I'm not as familiar with those because I concentrate more on the climate change, on the forest carbon accounting and policy aspects of that. There are sources out there, though. If you send me an email, I will try to hook you up or connect you with somebody who might be able to provide that information to you. But that's not the type of thing that I know off the top of my head. Are there policies that encourage keeping forests as forests? Absolutely, right? I just can't talk about whether a current use system for taxation does it. And we need forests. We need policies to keep forests as forests. That's a critical part of this whole equation.
Okay.
Other questions?
Good. Thanks, Bob. I'm especially pleased by your passionate defenses of science. Hey, and pricing, that's so unpopular these days, Bob, this science stuff. What are you doing? Overall, a great talk. I learned a lot. And sounds great. Thanks for the presentation.
And Jim, if I could just wrap up and say, if I can help any of you out there, please don't hesitate to let me know. I will, feel free to email me. I will tell you what Pamela Paul says when she gets to the end of the podcast for the New York Times book review. And she always says, if you send me an email, I will answer. It just may take some time. So
okay.
If I can help anybody, please let me know. But thank you very much. And Jim and Mark, thank you very much for the opportunity. I appreciate it.
You're welcome, Bob. What email address should we give people? Is there one that you can read off to us? That
yeah, I don't know if everybody will get it, but I'll read it off. It's RW. My name is Robert W. Malmsheimer. So it's RW and then the first 6 letters of my last name. So it's RW, M as in Mary, ALM as in Mary, SH at ESF, E as in Edward, S as in Sam, F as in Frank, .edu. So it's RW MALM SH at ESF.edu.
So you can always send an email to me and I'll get it to Bob.
Thank you, everyone. Have a great day and have a nice weekend.
The presentation's coming up next week and the week after. You can go to our website or you can go to our Facebook page and learn what those are. We'll be sending out emails in the future as well. Next week, state-of-the-art biomass heating with Froling boilers. And that's one of the manufacturers we've used for a good while here of a very high efficiency boiler. They make not only wood pellet boilers, but dry wood chip boilers. And the distributor here is right here in New Hampshire up at Tarm Biomass in Orford. The president of Tarm Biomass will be giving that talk, and he'll be digging into the technology. The key is to understand the boilers, the applications, but how the systems work, what goes on inside the boiler, and to find out some of the variety of different types of boilers that are out there. And to follow on with that, another boiler company that we've dealt with for a really long time as well, 10 years, is Main Energy Systems. And they have what's called the Okathon boiler that they have now been assembling in the United States. It's by them, MESYS, Main Energy. And they, again, have a great boiler that's proved to be incredibly reliable. It's a pellet boiler system in a number of different sizes, and that they're going to be talking about in November. Now, I just want to make clear, We actually have 3 sessions in November, and 2 of them are going to originate in Europe. So in order to accommodate the time difference, we've scheduled all the November sessions to be 10 a.m. on Thursday as opposed to 3 p.m., which today and the next session are at 3 p.m. So we just split it by the month and said October is 3 p.m., November is 10 a.m. Like I say, Schmid is a maker of very large-scale biomass boilers, very high efficiency boilers. And they have another long history of manufacturing boilers over in Europe. This is a Swiss maker. The other 2 are originated in Austria. And we find that the European boilers are just the top dog. They're the way that if you're going to get an efficient boiler that's clean burning and has the right characteristics and, advanced processing of monitoring and so forth, that's the thing to use. So the Schmid boilers will be reviewed. So it's 1, 2, 3. If you're into boilers, I guess we've maybe overdone that a little bit, but there's 3 different boiler types. They're different. They're all different. And then finally, there's a project report. We call it a Euro project report in this case, because I wanted to be able to show people what's going on in Europe. There's a small district heating system that originates at a big juice company in Switzerland. You've probably never heard of them before, but Bayata. They have an 8 million BTU boiler. That's a pretty substantial boiler, and they're processing steam as well. So that's a steam boiler, and that's a bit different. All the other boilers we have are hot water boilers. Schmid does give us that steam option, so we'll be talking about that. So if you want to know something about boiler technology, those 3 sessions coming up next, and then the 4th session and final before Thanksgiving. And I think we won't do anything until next year again. But that final session should be very interesting with the people from Schmid giving a talk about, I think it's going to be 2 or maybe 3 installations. But the primary one is this juice manufacturing company. Visit our YouTube channel, where we've got a good number of recordings right now of some webinars that we did over the summer, and some other videos as well are there that have to do with our boiler systems and some of the work we've done. If you want to see some installations of boilers that we've done here in Vermont and New Hampshire, I recommend that you take a look at some of those videos. One in particular talks about schools, and another one just goes through a number of different installations of biomass boiler systems.